Okay. Good morning. Welcome to the next Inf 3331 lecture. There's actually only 2 lectures left, so you're almost done. Today I want to show you how you move from a script, which you've already written kind of modules, but at the moment they were kind of self-contained programs. I want to show you how you move from these programs to proper projects that might be used by other people, that have a website, that maybe have automated testing, and so on and so forth. And so some of this you might already have seen in the past lectures, but I will also tell you in addition some of my best practices that I use in my projects to make my life easier. So a lot of this is kind of best practices today. And then next week, I want to show you some of the more advanced modules that we have available, or packages that we have available in Python. So I will introduce you to Scikit-Learn, which is a machine learning package in Python. And so this is not part of the assignments, but it's an interesting application that you can see how, once you know kind of this Python language, how quickly you can experiment with new tools like machine learning. Yeah. Before we start, I just wanted to, so I've looked at some of the peer reviews over the last days, and I think I was really impressed how well this pull request-based interaction worked. So it seems like a lot of you have given really good feedback, and also that the people who received the feedback appreciated the kind of the code changes. So I'm just wondering how we should do the last peer review, right? There's assignment 6, and so we have the choice. We could either do another LaTeX-based peer review, or we could do another pull request-based peer review. So if you have any, at the moment I'm leaning towards doing another pull request peer review. And so maybe you even want to merge in the changes so that you create a pull request and then the other student has to merge it in, and you kind of, maybe you even want to have a discussion, what should be changed. And so, but if you have any strong opinions, then just let me know per email. Okay. So what we want to do today, and I will also show you some more advanced Python stuff. So I will teach you decorators in the second part of the lectures. But now we talk about from script to project. So the typical steps that you want to do once you've written up your script and you want to make it more applicable to other users, is that you want to move your script into a package and make it available as modules. Then you want to add documentation. This is something that we're already very familiar with. But then what we haven't really discussed is how do we make our code available. And typically what you want is you want to have a project website, and you want to have maybe online documentation so that you can quickly search through the documentation. Also something that we haven't talked about is how do we handle errors in our scripts. Right? So far we haven't really discussed errors at all, and we just assumed that things will just work and the inputs that the user provides are all valid and so on. So we need to talk about how we can handle errors robustly. Then, of course, very important are tests. We've discussed this briefly. I want to show you something called automated testing later on. And then, of course, an important step is to add instructions on actually how to install your software. And I will demonstrate this procedure now on the Monty Hall game that we implemented 2 weeks ago. Remember this website that we coded up where you could choose a door and then you kind of opened that door. Well, no, you chose a door and then the TV moderator opened another door, and you could either stick to your choice or change your choice. But if you remember how this was coded up, essentially we just had a core directory where we coded up our game server.py. So that was this Flask server. And then we had a bunch of template files. But now, let's say we wanted to go further than that, and we wanted to make this game now available both as a command line interface and a web interface. Right? So maybe some users, they don't have a web interface and they just want to test it on the command line. So we would like to provide both. And we would like to add online and offline documentation. We would like to add tests, and we would like to add error handling. And so these are kind of the steps that we will take now. So the first step that we're going to do is to organize our script into modules and functions. And the key motivation here is that if we want to provide both a command line interface and a web interface, it makes sense to separate the game logic from the actual user interface. Right? So we want to have one core module that implements the game logic, and then we can have additional modules or scripts that implement different user interfaces using that game logic. And the way I structured this is that I created one module or one package called Monty Hall game. So this is now my new directory structure. So I still have a project folder where everything will go in. And then I have a Monty Hall game package. So remember, package is just a directory with an init file in it. And then I have a Monty Hall game.py file. This is my module that implements the core game logic. And I'm going to show you the implementation in a second, but I first want to show you how this can now be used, this module. So once it's implemented, the idea is the following. So you can, first you import the Monty Hall game. So from Monty Hall game, this is the package name, import Monty Hall game, which is the module, the class name. So then you can create a new game. It's often quite useful to, before you start implementing, to think about what would a good interface look like. So you could even draw something like this up even before you start coding it up. So it makes sense to kind of first create a new game, because maybe you're running multiple games in parallel, right? So then each game you can select a door. So it needs to have a parameter which door you want to select. Then you ask the host to open the door. That returns a number, so the host opens the door number 2. Then you have to select another door again, so you can either choose the same door or another door now. So here I chose number 1 again. And then at the end you say open door. I call the open door function, and it either returns true or false depending if you have won the game or not. And then finally, a interface that I provide is the statistic function that shows or that returns how often which strategy worked how well. Okay, so this is the user interface that I thought might be useful. And so we can look at the implementation. So this is this Monty Hall game module. So you can see I defined my class. I have this stats function here, which is collects all the statistics of all games. I'm not sure if I've shown this to you before. This static method. This is a function that is shared across all object instances, right? So the statistic function you can call. You don't have to instantiate in Monty Hall game object first. You can just write Monty Hall game .statistics and call that, because the statistics is nothing that is related to a specific game. It's shared across all games. so the statistic functions prints out the statistics, and then we have the implementation of all these different functions that we've just talked about: selector, available doors, let host door open, and so on and so forth. And then at the end, what I often do in my modules is that I have an if statement, if name equals main, and then inside that if statement, I present an example on how this module can be used. And the purpose of this if statement is that the code here is only executed if you run this module as a Python script. So if you run Python Monty Hall game, then this code here will be executed. And if you import Monty Hall game, then this code will not be executed. And so this is useful because it shows if someone opens that file, it's very obvious on how how the module can be used. So one important thing here that I haven't talked about is the init file. So remember, every package needs to have the definition of making a Python directory a package is to add a init file. And so far, our init file was just empty. But sometimes it actually makes sense to have some code in there. And the reason why it makes sense is because the init file is automatically being called, the code in the init file is automatically being called when you import that package. So when you write from import Monty Hall game, then automatically this code here is executed. Now, I want to show you if I had an empty, we change the so my Linux laptop broke, so now I'm on my old Windows machine, and it's really slow. I'm sorry. So what I wanted to show you is that if I have an empty init file and I open an IPython shell, and so now if I write import Monty Hall game, this is now the package name, right? But then inside that Monty Hall game directory, I have the module name, which is also called Monty Hall game. So now I need to write .Monty Hall game. And then inside that module, I had the class name that I'm actually interested in, right? Which is the Monty Hall game class here. So now I would have to write from this import Monty Hall game, which is not very nice, right? So I mean, here it's just 2 layers, but sometimes you have even more nested directories, and you end up kind of from Monty Hall game user interface import Monty Hall game. So it becomes very, very lengthy. So the trick, what you do is that in the init file, you simply import the classes and the functions that you want to have exposed automatically when you import the package. Right? So when I type in here from .Monty Hall game import Monty Hall game, now if I restart this IPython shell, I can just write from Monty Hall game import Monty Hall game. Because this is now being automatic. This import now from the class Monty Hall game now happens automatically. So this is the purpose of actually, and it's very common that in your init files you just import the relevant user interface that you want to expose to the user. Does that make sense? Yeah. So now we've got this. Now we've got the core logic implemented in a nice module, in a package. So now what we do is we create two scripts that implement the user interfaces. And I have one script that implements the command line interface, CLI for command line interface, and another one that implements the web interface. And so typically what I do is everything that can be executed, I put in a subfolder called bin for binaries, which is, even though these are really scripts, but just out of convention reasons, I put them in a folder called bin. And so here now, I always know if I'm in one of my project folders, in bin, these are all the files that I can execute. And of course, these files are now fairly short because they can rely on the game logic. So if you look at this, the command line interfaces, this is the entire file. So essentially, up here, I import the game logic, and now you can see I don't need these dots. I don't need the package name.module name, but I can just use the short notation. And then essentially, it's just a big while loop where I print some stuff. I start a new game, right? And I just guide the user through the game, and I collect inputs and print statements as we go along. And the same thing is with the web interface. So now the only difference is now I need to Flask, but essentially it's exactly the same thing. It's just reduced, and I could kind of strip out the game logic. Okay, so that's our first version. Now we have two different command line interfaces and a core module. So then the next thing that we should always do is to add documentation, right? And so we already know how to do that. We have to go into the relevant parts of the code and add doc strings. And there's various different ways on how you can add doc strings. There's no specific standard on how to do it. What I often do is I use the docstring standard that is provided by Sphinx, and I will show you Sphinx in a second. But if you open up this link here, then you will see an example on how a Sphinx docstrings look like. So this is kind of a sample code. So essentially, well, this is an example for a class docstring. Right? So you have one line. That's often a good practice. You have the first line should be a summary of what this class does in one sentence. And it's, by the way, it's the same if you write commit messages. The commit message, the first line should always be kind of a very brief summary of what the commit does. And then you typically have a new line, and then you have a more detailed description on the class. Right, and so then, I mean, this is, you can look up the syntax itself. But the point here is that you can have, you can specify the parameters that go in, and you can specify what it returns, right, and potentially even the return type. And then you can have examples where you provide some sample code. There's an example code on here, for instance. This is how you do example codes. And of course, you could even do doc tests examples that are being executed automatically when you do testing. This is what Jonathan showed. But so let's have a look at how I've documented that code. So I kept it very simple. My Monty Hall game class, essentially just I added one example because I think that's always very useful. And probably the best documentation to show how is it being used. Yeah, and so I essentially just went through all my classes and my methods and added doc strings. Nothing too spectacular here. And of course, so once you've done this, we can query our documentation using in IPython anyway, using the question mark. So then if I open this, I get the nice documentation that I've just written. Fine. But often we want to see documentation not just while we're coding, but also as a website somewhere. And there are two tools that I want to show you how you can convert. The point is that we don't want to write documentation again in a separate website. We want to write the documentation in the source code as doc strings, and then automatically convert the doc strings into a website that summarizes the documentation of maybe just a function or an entire module or maybe of an entire project. And there's two ways on, well, at least two ways on how you can do that. One is called PyDoc. And PyDoc is a tool that is automatically part of every Python environment, so you don't have to install anything. And there's essentially two ways on how you can use PyDoc. Either you write PyDoc and then a Python file, and then it generates a text documentation, a text format documentation of your Python file. But it can also create an HTML version that you can open up in a web browser. And you just use PyDoc -w for web, and then the Python file. Right? So now, since we've documented our Monty Hall game, we can benefit from this. So I just run PyDoc 3. Well, it should be PyDoc 3 if you're, of course, we're using Python 3. So PyDoc 3, and then here's my path to the module. And so here we get a nice summary now of this module in text format. And you can see kind of which classes are contained in that module. And then here's the example that I've coded up before. Okay, so that's the first thing. Or the second thing is that we could add this -w. And then you can see it generated a new file, montyhallgame.html. And this is now a HTML file that we can open up in a browser. You can also look at this. So here's my HTML file. I click on it. There's a beautiful color scheme. But essentially, you can see that's the same information as we've seen before, but now in a nice website. So here's our class, here's again our example, and here are all the different methods that we've implemented, and including the what it does and what it returns here. That's what I've documented in these cases. Right, but so PyDoc is still quite limited in that it really only works for individual modules, and it doesn't really allow us to create a proper website of our projects. And so Sphinx is a more advanced program for doing documentation of your projects and has a lot more flexibility. And Sphinx is typically what I use in practice. So I can show you, so this is one of my research projects that I have, and I use Sphinx to document that. And just to give you an idea roughly on how this could look like, a finalized Sphinx documentation. Right, so what you have is you kind of have a nice style, and you have so this is what when you come to the website, this is what you first see. Right, you can have kind of slider images and some describing text. Features, how to get started, some news, okay, some content overview. And now, for instance, let's look at one of the examples. Some examples here. So here's one example, and you can see this. I first always show what the results look like, and then I actually have examples as code, but that code is then automatically ends up in the documentation like this, where I always have some text and then some code lines, and some more text and some code lines. But overall, this essentially documents the entire example. So there's a lot of details. And then at the end, I show how to run this example. So a good web page should have some examples. And of course, there's then also the programmer's reference that lists all the different modules that we have in this package. So this is essentially now what you've seen before, but just a lot more advanced. Right? So here's this is a steady shallow water problem class. You can see this is a class. And this is, I have some documentation here, but the class documentation actually contains some mathematics, for instance. And then down here, you can see all the different methods that we have here. So there's actually another class here with some variables, and so on and so forth. But the point here is that this entire documentation is contained in the project, and it's automatically generated from the source code. Right? So when I change the source code, when I change the doc strings of the source code, then automatically this website is being updated. So how do you do that? Well, first we have to install Sphinx. It's part of the pip package system, so you can just do pip3 install Sphinx. And then essentially there are two important steps that you need to do to get started. When you're in your project folder, you have to run Sphinx quick start, and then you provide a folder where the documentation should end up, where it should be generated. And so I typically put my documentation in a subfolder called docs. So I call it Sphinx quick start docs. And then you need to tell Sphinx which modules it should document. And there's a way on how you can do that automatically. You use Sphinx apdoc -o doc, so this is where the documentation files should end up, and then the modules that you want to have documented. And then you do that for every module that should be part of your documentation. And then you can edit these RST files. This is rich text format files that you can change the home page, and you can add more pages, and so on and so forth. But I think it's best if I just guide you through this, that you see what it looks like. So let's go here. Right. I hope I'm doing this quickly. Yeah. So what I do is I'm in my project folder here, and I have already doc here, but I'm just creating another documentation now, just to show you what I'm doing. So I do a Sphinx quick start, and I provide the folder where I want to store my documentation, so I just call it doc2. It takes some time, and then you have to provide a bunch of answers. And I just leave most of it. I leave the default parameters for now. I need to provide a project name. So I call it Monty Hall game. An author, it's just me in this case. Project release, maybe 1.0. 1.0. Okay, this doesn't really matter. So here it asks me, these are at the end, it asks me which kind of extensions I want to have enabled as part of my documentation. There's one called autodoc, automatically insert doc strings for modules. This is something that I want. I want to automatically have the doc strings for modules. So I say yes here. there's doc test, automatically test code snippets and doc test blocks. So you could do that. I just say no here. Right. Loads of different things that we don't really care about, including mathematics, for instance, which we don't need now. This is quite nice. View code include links to the source code of documented Python objects. So let's just say yes to this one for now. And it's asking me to create a make file. This is what we want. OK. So once I've answered everything, you can see that it created 4 files in the doc2 folder. So I can go in there now, can do an ls, and I can see kind of these are the main 4 files: makefile, conf.py, index.rst, and make.bat. And so at the moment, it's a fairly empty documentation, but I can already create it. The way you compile that generation, so how you convert it with the doc strings into HTML code is by writing make HTML. So you could even, let's take some time. And so now it says HTML pages are in _build HTML. So now I can go into my project folder, doc2, build HTML, and these are my generated HTML files. So I can click on index. And there we go. This is our documentation for now. You can see it's fairly empty. But the name has already been inserted, and we have some links to the modules. But at the moment, we haven't told it to document any modules yet, so this is just empty for now. But that's the first good start. So the next thing is that if we go back to our slides, the next thing was to add documentation for each module that we're interested in. So for that one, you use the Sphinx API doc command. So let's do that. So I just need to export that folder. So now I say Sphinx API doc. The output of where this -o, this is where my documentation is stored. So I provide again doc2 as the folder. And then the package name that I'm interested in. So that was Monty Hall game. OK? And so now you can see it created 2 more files in my doc folder, one montyhallgame.rst and one module.rst. So we can have a look at this. Let's look at montyhallgame.rst. And I'm sorry, the contrast is really bad. I hope you can see that. There's essentially, here it now lists the 2 modules that I have. And one I haven't explained yet. One is called game exceptions, and the other one is the Monty Hall game module that we already know. And you can see here there's this auto module that essentially tells things to open up that module, look at all the functions and all the classes in there, and automatically extract the doc strings and document them. And so in principle, this is editable text, right? So if you could say, maybe I don't want to, I'm not interested in documenting this exception module. So you could just remove it, and then Sphinx wouldn't add it anymore. Or you could also change the titles and so on and so forth. But the point now is, I can now run make HTML again. Now it rebuilds the documentation. And this time, it should also have documented our modules that we told it to. So I can now reload this, but now it's still, the landing page is still empty, but now if I click on module index, now this exists. And you can see here my 2 modules that I have. And if I click on this first one, for instance, here is now the documentation of the Monty Hall game module. And you can see that it's now really nicely highlighted because we used the right syntax. So the example has a nice gray background and has Python highlighting. Down here, the return values, this is bold, and so on and so forth. Because yeah, Sphinx now automatically converts this into a nice website. And so, of course, then what we would like to do is maybe have if you open up this index.rst file, this is the landing page. So at the moment, this file is just empty. But it makes sense to kind of add some text here and say, what is this game about? And so I just copy maybe a nicer one in here. This is how a nice, maybe a better landing page might look like. Right? So I have some titles, I have some text, one line describing what it is, just a quote from Wikipedia. Down here I have a section on installation, and then how to start the game. And you can see here again I use the Sphinx Sphinx formatting, so you can look this up also on the website and how one should do this. But essentially what you can tell Sphinx is that some of the text should be interpreted as code. So here I have ... code block : bash, meaning that the next two lines are bash commands, right? And then Sphinx uses its special bash highlighting to visualize that. So essentially you do that, and then you do make HTML again to update your documentation. You reload your web page, and suddenly you have a really beautiful project web page, right? With a quote from Wikipedia, some installation instructions, how to start the game. And then if you click down here, you get the code documentation. Okay. So now our new the new files that we now have to add to our projects are the following. We just add the doc folder, including this is the configuration file, and then all the RST files and the make file, one for Windows and one for Unix. I also maybe wanted to show you, this is quite nice because, so of course, make HTML produces a HTML file, but you can also provide other stuff. So for instance, if you, well, there's no PDF here, but there's, for instance, it's difficult to see, but there is you can create LaTeX files, and you can automatically create a PDF version of your documentation, right? Or maybe you want to have, various different formats that you might be interested in. And so the final tip here that I want to give you is that there's a project called Read the Docs. And what that does is it essentially, you hook up your GitHub repository to Read the Docs, and then Read the Docs will automatically compile your documentation whenever you commit something to your GitHub repository. So the idea is you just have your code repository, you make your changes, you commit them up, and then automatically Read the Docs realizes that, compiles documentation, and updates the website. And so if you, actually both, this open title farm website that I've shown you, if you look at the URL, you can see it's opentitlefarm.readthedocs.io. So I actually host this particular documentation using Read the Docs. And I don't really have to do anything anymore with the documentation. I just make my code changes, commit, and I know that the documentation and the website updates automatically. Next step. Now we want to improve our error handling. And we haven't really done any error handling at all. So for instance, if you run my command line interface, you're being asked to select a door between 1 and 3, and you can just type in 5, which clearly doesn't make any sense. So we should be able to handle errors like this. And in Python, there is a concept for error handling that is exception-based. And that's what I'm going to talk next about. And so you've been, so this topic, the next section is about error handling in Python. And you've dealt with errors all the time in Python already. So I'm sure you're very familiar with errors. For instance, if you take a number and you want to divide it by, if you take a number variable x that is equal to 0 and you want to divide 1 over 0, you get a Python error. And specifically, you get a zero division error. Right? It's a very specific error that for dividing something by 0. And it also tells you where the error occurs and then an error message. But essentially, this is the error type. It's a zero division error. And then you have a message that specifies what you've done wrong. The same happens, for instance, if you're trying to open a file that doesn't exist. So open hello.txt. So here you also get a different type of error. You get a file not found error, and then a more specific error message here. Another error that is quite common is if you're trying to, if you have a list and you're trying to get an item that is outside the range of the list. So here I have a list of 12 items, and I'm trying to get the 13th item, or actually the 14th. So in that case, what you get is you get an index error. So it tells you the range object index is out of range. Right? So again, this is the index type, and then we have an error message. But in Python, even syntax errors are normal errors. So here I have a simple function where I forgot the brackets. And if I try to run this, you can see even syntax errors are just handled like any other error messages. So here we simply get a syntax error and with a more specific error message. So now, after the break, I will show you how we can create our own error messages like this, but also how we can handle them and how we can deal with them and maybe fix them while we are running the program. So let's start again at 13 past.